Hi guys. I'll be out sick today, and I decided to create this video to go over lessons 4B and 4C. I know that we started on 4B, but we have not really finished it. So here's a continuation on this. I remember we went over briefly over square roots, and then we talked about square root of 4 equal to 2 because we said 2 multiplied by 2 equal to 4. And then similarly, square root of 9 is equal to 3 because 3 multiplied by 3 is equal to 9, and so on. Okay, so for 16, 4 multiplied by 4 is 16, and therefore square root of 16 is equal to 4. Square root of 25 is 5 because 5 multiplied by 5 is 25, and so on, and so forth. So please make sure you complete this in your packet, and make sure you've been completing your homework on a regular basis so you don't get to a point where your homework is stacked up and you need to go and complete a bunch of homework right before your unit test. And by the way, you have a quiz on 4A through 4D next Monday. We'll talk about that next time when I'm back in class. So for example, one, it says find each real number. So they call them the principal square root, okay? The principal square root, which means the main square root. So square root of 16 is 4. If this is a repetition, I do apologize. 75, if you remember, is 3 and 25, and then 25 is 5 and 5. So we call 75 a composite number. So you can see you have two 5s multiplied and a 3. The two 5s become a 5 on the outside. So this is 5 square root of 3. If you forget, you can write square root of 75 as square root of 3 times 5 times 5. And the two 5s here go outside as 1 5. Okay, and you get the same answer of 5 root 3. For square root of 80, same idea. What I recommend that you do, if you get to a point where you're more comfortable with the numbers, try to get a perfect square out of a number. Like for example, in 80, you have a 16 times 5. If you see that, you're saying square root of 80 is the same as square root of 16 times 5, and 16 becomes a 4 on the outside. So this is really 4 square root of 5. Okay, and if you don't, it'll take you a little bit more work, and then you can do really the tree factorization or the prime factorization. 2 and 40, 2 and 20, right? 2 and 10 is a little bit more work, 2 times 5, etc. And then you can see two 2's become 1 2 on the outside, two 2's become another 2 on the outside, and you're left with 5 by itself on the inside. Remember, when you throw numbers outside of the square root or any root, they multiply. So this is 4 square root of 5, which is exactly what we have here. Okay, for 30, we cannot break it up. It's 2 and 15, or 2 and 3 and 5, so this stays. This is the answer itself. For 18, 18 is 9 times 2, right? And 9 becomes a 3 on the outside. And you already have a 3. So it's 3 times 3 square root of 2, which is 9 square root of 2, basically. Okay, so that's how this works. 8 is 2 multiplied by 2 multiplied by 2. So you have 3 2's on the inside, and that's 2 2's become 1 2 on the outside. That multiplies by the 5, so that's 10 square root of 2, and you're done here. And square root of 30, that was repeated. Again, I think we went over some of these guys, but anyway, this is a review. 8 is the same as number 5. These are repetitive. So then for numbers 9 through 12, so let me clear this up. For numbers 9 through 12, 3 square root of 6 minus 5 square root of 6, you just, because the radical is the same, right? Because here you have root 6 and root 6, you can subtract. And you only subtract, you do 3 minus 5, technically, right? So 3, think about it as 3a minus 5a. The answer to that would be what? Negative 2a. So the same idea with roots. 3 root 6 minus 5 root 6 is negative 2 root 6. And here the same thing, but careful, the radicand, which is the number under the radical, is not the same. So you have square root of 3 and square root of 27. Therefore, you cannot add them. You cannot add them. It's very much like having a's and b's, right? You can't add them. So for you to be able to add them, they both need to have the same radicand. They both have to maybe have square root of 3. But this doesn't, right? So let's see if we can simplify it. Remember, 27 is really 3 times 9, which is 3 times 3. So 27, if I'm taking the square root of 27, I'm taking the square root of 3 times 3 times 3. That's 27. And 2 3's become 1 3 on the outside. So this is 3 root 3. Okay, so now be careful here. The 27 itself is 3 root 3. That's the 27. But then there was a 3, this 3 here on the outside, which is going to multiply the 3 that came out of the 27. So this becomes negative root 2 root 3 plus 9 root 3. Again, remember this was the 27, which is the 3 root 3, but we had 3 times root 27. That's what that is. So it's technically 3 times that, which is 9 root 3. Okay, so it's negative 2 root 3 plus 9 root 3, and that's 7 root 3. So just be careful with these radicals. Similarly here, what I would do when you see square root of 6 and you know you cannot simplify square root of 6, think about a 6 out of the 54, and it's 6 times 9, right? So the 9, so this is 2 root 6, the first term, plus the 9 becomes a 3 on the outside, and that's going to multiply by the already existing 3, so that's going to be 3 times 3, which is 9, and 6 is left on the inside. So this is 9 root 6 and 2 root 6, which is 11 root 6. Okay, and similarly, so here you can see 7. Let's see if we can get a 7 for all of them, because 7 is prime. 28 is 7 times 4. We know that. 63 is 7 times 9. So from the 7 times 4, the 4 is going to go out as 2. 2 rad 7 plus, here you have a 4, the 9 goes out as 3 to multiply the 4 on the outside, so that's 12 root 7, and then minus 2 root 7. So they all have the same radicand. They all have square root of 7. The word is radicand. Okay, and that's the number under the square root. We call it radicand. So 2 root 7 plus 12 root 7, that's 14 root 7. Remember, the root 7s don't add, okay? They're just like a fixed variable, like a. I shouldn't say fixed variable, it's an oxymoron, but as square root of 7 and square root of 7 don't add. You add just the 2 and 12. So it's 14 square root of 7 minus 2 root 7, we're back to 12 root 7. And this is basically it. I'm going to let you try A and B on your own. And once you get the answers, you can check on with me when I'm back, and we can verify whether they're correct or not. Okay, so let's move on to the next part here. Example 3, multiplying. And again, I'll do 13 through 16, and then you can try the rest on your own and verify they're correct. So for when you multiply, here's the thing. When you multiply root 6 by root 6, you technically get root 36, which is 6. So this is 6 times 4. This is 6 times 4, which is 24. Okay, again, when you multiply a radical by itself, when you multiply any radical, let's say root 3 times root 3, the answer is just 3, because you're getting really root 9, and that's the same as what? As 3. So here, when you do root, negative root, you can do it in 2 ways. The rule says root of A times root of B is equal to 1 square root of AB. So you just can put A and B, the product of A and B, under one radical. So here, you can say this as negative square root of what? 5 times 20, which is 100. And you know square root of 100 is 10, so this is negative 10. You're done. Okay, when you have something like 15, you're going to distribute to the inside. So this becomes 4 root 16, because root 2 times root 8 is root 16, and then plus 5 root 2. You always say a number root something. You don't say root something a number. It's not conventional to do that. And also, I fear that someone will extend the radical sign and include the 3 underneath it, which is problematic. So again, you always put number radical. You do 2 square root of 6 or 7. Okay, not square root of 7, 2. You don't write that. So anyway, this is for this. And then don't forget to simplify. So you cannot keep this as is, because square root of 16 is 4. So this is 4 times 4 plus 5 root 2. 4 times 4 is 16, so this is 16 plus 5 root 2, and you're done. Okay, you always need to simplify radicals. Now, square root of 2 minus square root of 3, quantity squared, you can write this twice, like this. That's what's meant to be. Okay, if you know how to write this as a perfect square trinomial, you do, which is the 3 terms. We talked about this previously. If you don't, this is in the form, basically this is in the form a minus b quantity squared, which is a squared minus 2ab plus b squared. If you remember that, good. If you don't, you can write a minus b squared as a minus b times a minus b and then FOIL, right? You can still do that. So let's say if you forget that this is a perfect square trinomial, so you can write it twice and FOIL. You get square root of 2 times square root of 2, that's square root of 4 or 2. Square root of 2 times negative square root of 3, that's negative square root of 6. And then negative square root of 3 times square root of 2, that's negative square root of 6. And then lastly, the last two, negative square root of 3 times negative square root, that's positive 3. So you get 2 plus 3, which is 5, and then minus square root of 6, or negative square root of 6 minus square root of 6, which is negative 2 rad 6. And then you're done. This is the answer. Okay, so you try these on your own and see what you'll get. Notice this is in the form a minus b here, multiplied by quantity a plus b. So remember what form that is. This is very similar to this with a plus in the middle, and this is very similar to that with a minus here. So it's very similar, these items, okay? So try them out, and we'll confirm answers next time when I'm back. This is your homework, so maybe I can start with a couple of questions here. Let me start by doing, helping you out maybe with, let's see, 6, right? 75 is 3 times 25. I took a perfect square out of 75, which is 3 times 25. And 12 is 4 times 3. And 50 is 25 times 2. So I can break it into perfect squares and non-perfect squares. So here, the 25 goes out as 5. It multiplies by this goes out as 5. And it multiplies by the existing negative 2. So this is negative 10 square root of 3, because this is gone to the outside, and you have 3 left on the inside. Then I think it was positive. It's a plus. Yeah, it's a plus between them. So then plus, notice this 4 is going to go to the outside as a 2. So it's going to become 2 times 7, which is 14 rad 3. And then this 25 becomes a 5 on the outside. So it's going to be 3 times 5, which is 15 plus 15 rad 2. Now these two have radical 3, and this has a radical 2, which is a different item. So you can only combine these together. 14 minus 10 is 4 square root of 3, and then plus 15 rad 2 that doesn't have anything to combine with. Okay, so this is one of the homework questions. Try the rest of them. It's your homework, so make sure you try it, and maybe let me help you with a square root of 20 here. 20 is 4 times 5. We already talked about that. The 4 goes out as 2, so it's 2 rad 5. 2 square root of 5. Okay, let's move on to the next lesson, which is lesson 4C. So simplifying radicals. This is cube root. Cube root, very much like square root, but it's what number do you multiply by itself 3 times to get 8, right? The answer to that is 2. Why is that? Because 2 times 2 times 2, this should be another 2 here. There should be another times 2, equals to 8. And then cube root of 27 is, excuse me, cube root of 27 is 3, because 3 times 3, there should be again another times. 3 is 27 because it's cube root. And then cube root of 64 is 4, because 4 times 4 times 4. Add a times 4, okay? Is 64, and then same thing for 5. Because 5 times 5 times 5 is 125. Okay, so let's try it out. Cube root of 27. 27, we already know it's 3 times 3 times 3. So the cube root, the job of cube root is to get 3 items at a time. Square root, the job of square root is to get 2 items at a time and pull it out as 1 item, 1 representative to the outside. Cube root of 27 is just 3. That's the answer. Now, cube root of negative, okay, what number do you multiply by itself 3 times to get negative 27? It's negative 3. got it. -3 times -3 is +9 times -3 is what? Is -27. So this is -3. Now 54. 54, if you break it up, it's 2 and 27, and you already know 27 is 3 3s multiplied, right? So from here, you have 2 and technically 3 cubed, or 3 times 3 times 3 after that. Right? So the 3 3s become 1 3 on the outside, and they go to multiply the existing 2 here. So that becomes 6. Don't forget it's cube root, okay? And I always tell the students to be careful here. Is a small 3. The cube root is a small 3 on the radical side. And then what's left on the inside? We added 2 left on the inside because the 3's were gone. So this is 6 cube root of 2. And so on. 24, if we want to try 24, 24 is 2 and 12. And 12 is 2 and 6. And 6 is 2 and 3. So you could see 3 2's in the 24, right? And that's going to go out as 1 2. And what's left? The cube root. Don't forget the cube root. It's a cube root now of what? Of 3. That's what's left on the solo 3. Same thing with 128. If you see a perfect cube in the number, just take it out, just like you did with perfect squares. Here 2 and 64. I know 64 is going to be 3 4s multiplied. So these 3 4s become 1 4 on the outside, right? But when they go to the outside, they're going to multiply by the existing 3, which is 12, because 4 times 3 is 12. And what is left? Actually, this is going to be negative. Don't forget, these are negative. It's negative 12. And then what's left on the inside? Cube root of, make sure this is on the radical. Cube root of what? There was a 1 solo 2 left on the inside. Okay. And so on. So you can try 40. 40 is 2 and 20. 20 is 2 and 10. 10 is 2 and 5. So we can see you have 3 2's. This is going to, and the 3 2's become 2 on the outside. That multiplies the existing 2. So that's 2 times 2, which is 4. Cube root of what? What's left? There's a solo 5 that is left. Now, 4th root of 16 is what? And this should have been 4 times, I would say. So 4th root of 16 is what? Is, what number do you multiply by itself 4 times? You get 16 is 2. And this is going to be 3, and this will be 4, and this will be 5. Why? Because really 2 times 2 times 2 times 2 equals what? Equals 16. And here it's 3 times 3 times 3 times 3, 4 times. This is equal to what? 81. And this is 4 times 4 times 4 times 4 is equal to 256. And one last thing here, it's 5 times 5 times 5 times 5 is equal to 625. So that's what 4th root. 4th root, again, if you have like 4 items at a time, it tosses them out as 1 item. Okay, and soon enough, we're going to talk about letters, how the variables, right? Here we're talking numbers. Soon enough, you're going to have 4th root of A to the 8th, B to the 7th, and so on, right? C to the 3rd, let's say, and how to clean that up, how to simplify. But anyway, so for now, let's try 4th root of 64. And let me see if I can scroll up. Let me keep it here for now, and then I can scroll up. So for 64, we already know 64 is 4 and 16, or 2 and 32. And then 16 is 4 and 4. And here the 4 is 2. Remember, you're breaking the number up to the prime factors. That's the job that you're doing here. This is the prime factorization. And if you remember prime numbers, they are 2, 3, 5, right? 7, 11, 13, 17, and so on, 19, etc. You're not going to need more than, I would say, 19. 4 is not prime, it's even. 6 is not prime, it's even. 8 is not prime. All the even numbers are not prime after 2. And then some of the odd numbers are prime. So this is how many 2's? 1, 2, 3, 4, 5, 6 2's, right? So this is saying you have 2 to the 6 here. We're taking the 4th root of 2 to the 6. 2 times 2 times 2 times 2, 6 times. You have 4 2's that you can take out as 1, 2. and then fourth root, how many 2's are left on the inside? 2 2's. If you take 1, 2, 3, 4 2's, you're left with 2 2's on the inside, which is 4. 2 times 2 is 4, okay? Now here, you have to be, this is not difficult. Fourth root of, it's 81 over 625. We just said that 81 was the fourth root of 81 was 3. We know that. So this, when you have a radical, just like I did earlier, when you had a radical of any radical of a times b is equal to radical a times radical e, or rad a times rad b. If you had the fraction, you can also split them into the rad of the top over the rad of the bottom. So here you can read this as fourth root of 81 divided by what? The fourth root of 625. And we kind of know, well, we know them right here. We just said that this is 5 and this is 3. So this is going to end up being 3 over 5. Okay, that's for number 8. And for number 9, number 9, you have 32, which is 2 and 16, and 16 is 2 and 8, and 8 is 2 and 4, and 4 is 2 and 2. You have 5 2's being multiplied, 5 2's. And this is fourth root. So this is 5 2's. You're going to take 1, 2, 3, 4 2's out. That's 2. And then fourth root of 1, 2 left on the inside. Okay, so this is how fourth root works. Basically, they all work the same way, really. For negative 16, now here, when you have a negative, when the radical is even, square root, fourth root, we don't, by the way, write square root, right? We just write square root, etc. When you have an even radical and you have a negative on the inside, right? You end up with no real solution, no real, aka what we're gonna learn as what? Imaginary, and the I squared. When you have an odd, like cube root, fifth root, seventh root, we're not gonna go as far as seventh root, and you have a negative, the answer is negative. So let's say you're doing cube root of negative 27, you would say negative 3, because negative 3 times a negative 3 times a negative 3 does give you negative 27. Okay, so in this case here, the reason I'm mentioning that is you have an even root, an even radical with negative. So this is really no real. If you think about it from the real world perspective, no real, right? Or no, not possible. But if you think about it from the imaginary world, right? You would say this is fourth root of 16 I squared, let's say, right? And then, or I to the whatever power, and then you you clean that up if possible. So you try to make it look like a to the fourth power. But in this case, you would say no real, right? If we're looking for the for a real solution or the real value, it's not a solution here. It's just you know, evaluation of the expression. So fourth root of 16, that's, remember 16 we said is 2 times 2 times 2, or 4 times 4, and each 4 is 2 2's. So it's going to be it's going to be just 2. And then here, same thing, 162. You always, your go-to method is to break the number up. And you know, one is 2 9's multiplied, and every 9 is 2 3's multiplied. So you have really 4 3's multiplied times 2. The 4 3's are going to go out because you have fourth root. They're going to go out as 1 3. And then don't forget fourth root of what? Of 2 that's left on the inside. So with this being said, let's try to, yeah, the homework is coming up. There's one more here. So let's kind of try to summarize this, right? So the summary of this is what? It says number of real nth root when n is even. So positive, negative, or 0. So number of real nth root when n is even. So let's say we're talking about the fourth root, right? And this is even. So this is this case, right? And the type of number, if the number on the inside is, let's say 16, which is positive, what do you end up? right? What do you end up with? And then for the odd, if you're doing, let's say, a cube root of a positive, right? So when you have a positive number under an even root like this, you end up with a positive value, right? When you have a 0, you always end up with 0. 0, whether you have cube root of 0 or fifth root of 0 or fourth root of 0, right? You end up with 0. The answer is 0 or 0. So when you have a number of a real nth root when n is odd, so when you have, let's say, cube root and you have a positive, what do you have? I mean, here they're saying a number. Yeah, it should be maybe the sign, right? Will be positive. Okay, this should not be the number of real nth root. Yeah, we'll talk about this in class. This should not be the number of, I think they meant, they meant probably the sign, right? They probably meant the sign. But anyway, let's skip this for now. I think they meant the sign. Let's skip this for now, the summary, right? And let's see how we can apply what we just learned in 1 through 12, right? It's a simplify expression, assume all variables are, there you go, assume all positive variables are positive. So if I get square root of x to the 4th, the answer is, so you're taking square root of x to the 4th, that's what you're doing. So every 2x's become 1x on the outside. Every 2x's multiplied become 1x on the outside. So this is x squared. Okay. And I'll show you a shortcut soon. I'll talk about a shortcut in class, right? But initially, you know how when you learn a method, you learn it normally initially in the longer way, so you kind of understand it, how it's expanded, right? And then you'd start learning the shortcuts for it. So I'll give you a shortcut about this in class. The square root of 16 times x to the, so basically 16 becomes a 4. X to the 20th becomes x to the 10th. Now, maybe this is a good time to give you the shortcut, because what you're doing when you're taking the square root, you really, if I say x to the 10, I'm taking the square root, I'm cutting the exponent in half. I'm doing 10, and remember, it's square root. I call it the in and out rule. In and out. It should be in and out like the franchise restaurant, in and out. So you divide in by out. You get 10 over 2, which is 5. Okay, so this x20 to the 20th becomes x to the 10. This here really was 4 squared. So you cut the square in half, you get 4 to the 1st, or just 4. Same idea. So 40 is 4 times 10, or it's 8 times 5. 4 times 10 is probably good. This is 4 times 10. The 4 becomes a 2 on the outside. The 10 is 2 times 5, it stays. So the 10 is going to, I'm going to put a little space here. The 10 is going to stay. X to the 6, you have 6 x's on the inside. 4 of them go to the outside, become 1x, and you're left with 2 on the inside. You have 3, actually it was square root, I apologize. Let's go back. It was 6 x's being multiplied. You cut them in half because it's a square root, right? You cut them in half. 6 of them on the inside become 3 of them on the outside. And then y cubed, you have 3 y's being multiplied. So you get 2 of them to the outside, become 1 on the outside and 1 left on the inside. And this is the final answer, 2x cubed y, square root of 10y. Similarly here, at 20 is 4 and 5. And 4 becomes a 2 on the outside. The 5 stays. Again, I leave a little space because I know some of the variables are going to the outside. X cubed, square root of that, you have 3 x's. 1x goes out, 1 stays. So you have 3. Okay, y is inside, it's solo. The z to the 10 becomes z to the 5th on the outside. Just be careful, don't move the 5 lot to the right. You don't want it to be right on top of the radical, right? You want it to show clearly that it's z to the 5th, not the radical is to the 5th or 5th root, and so on. So this is going to be x to the 4th, divide in and out, in over out. 12 over 3 is x to the 4th. Negative 27 becomes a negative 3, the cube root of that. And x to the 7, again, every 3, you have 6 of them. That will become 6 of them on the inside, become 2 of them on the outside, and you have 1 left because you had 7 total. So this is negative 3x squared, square root of x. And then, and so on and so forth. So for 128, that is 64 times 2. This is 64 times 2. 64, cube root of 64 is 4. You're left with 2 on the inside. Here you have cube root, so 3 of the x's go out as 1, and you're left with 2 on the inside. B to the 6, it's b, let me see, yeah, b to the 6 becomes b squared on the outside. And this is it. This should have been like shorter, the radical sign. Cube root of 32, 32 is 16 times 2, or you have 5 2's multiplied. 32 is 2 to the 5th power. So this is becomes 2. And then if you take 3 2's out, let me just make room. You have 2 2's left on the inside, which is 2 times 2, which is 4. Right. And then c to the 11, 9 of them go out as 3, and 2 of them are left on the inside. X is trapped on the inside. Y to the 5th, 3 of them go out as 1, and 2 of them are left on the inside. Okay, so let's try to finish this, excuse me, in the same fashion. And maybe let me do a couple more. But this is really the gist of it, okay? And we don't have to finish all of them, but you get the idea. So this is going to be, if you do the in and out rule, this is going to be negative y to the 4th power. You divide 20 by 5. And the negative goes out. Okay, when you have an odd radical, the negative goes out. This is none. Here, this is the same as saying 4th root of 16 over 4th root of 81. And that's going to be 2 over 3, 2/3. All right. Here, for this is 16 is 2 to the 4th. Really, 2 times 2 times 2 times 2 is 16. 2 to the 4th becomes 2 on the outside. You have 4 2's on the inside, and you have 4th root. So every 4 2's become 1 2 on the outside. And if you do the in and out rule, 12 over 4 is 3. So this is x to the 3rd. And you're done. Okay. Now, just be careful. And let me try one of the last ones here. I don't know what this is. This is like a missing typo here for 16. But for, let's say, 13. 13, you have a square root. The square root and square, they undo each other. Okay? They undo. And that leaves you really with what? Leaves you really with x minus 10. Because really, you're saying x minus 10 times x minus 10. You have 2x minus 10s inside. And you're taking the square root. So the 2x minus 10 become 1x minus 10 on the outside. Now, when you take things to the outside and you have nothing left under the square root, you actually are left with 1. Don't say 0, because square root of 1 is really 1. And that's why the square root is gone. Okay, if you say 0, the whole thing would be 0. So just be careful with that. Now, let's try here. This one, you have 5 of them, 5 of these. And you have cube root. Cube root takes 3 at a time. So this is going to be every 3 of these are going to become 1 on the outside. And then what's left? You have cube root of, you have 2 left on the inside. Okay, here, again, 8 and 4. 8 is a multiple of 4. So you're going to get x minus 3 to the 2nd power, in over out. And here, I don't know what this radical is. It could be, let's make it cubed, right? So if it's cubed, 3 over 3 would be what? It would be just 1, x plus 1. So make sure you make sure you watch this video completely, and hopefully this will help you. You can pause, review, and you're at 4C homework. Okay, so this will be it for today. Have a great rest of the day, and I'll see you next time. Make sure you complete the homework for both assignments or for both lessons 4B and 4C. Thank you for watching.